Hi students and all friends of mathematics, welcome. We are going to talk about integration by parts. So integration by parts is a special method of integration that is often used for when two functions are multiplied together, but it is also helpful in other ways. So you will see so many functions which are in the form of integration of u, xc, vxc, dxc, and you will be supposed to find the answer for this kind of integrations. So normally integration of this kind of functions is coming from, actually, mind you, derivative, differentiation is the opposite of integration. So you remember the product rule, when you were doing differentiation, like derivative of uv equals to u dv minus v plus v du. So if you're going to introduce integrals both sides, eventually you're going to get uv equals to integral of u dv plus integral of v du. So the integrals we are going to arrange it in this form here. You're going to have u and dv, and so you're going to have integral of u dv, and it will be uv minus now integral of v du. So being given two functions, how do you decide which one is u and which one is v? You are going to see it, but normally you are going to decide on u and v depending on some rules which we can see later on, dear students. But before we go there, I'm going to give you an example of questions in which you can see how we are using, actually, we are using integration by parts. So the first example we are going to see here today, let us start with this example here, integration of xc cosine x dx. Integration of cosine x dx. Integration of x cosine x dx, x cosine x dx equals to how much? So for this one, we are going to start with u will be x, and you're going to find, actually, du will be the x, and the v will be cosine x dx. You integrate, v will be sine x, and by using this formula here now, so the integral will be integration of x cosine x dx is uv, our u is x, times v is sine x, minus integral of v, it is sine x dx, dear students. So this is going to be x sine x minus integral of sine x dx, it is negative cosine x plus constant. So eventually we get now the results. So x cosine x dx equals to x sine x plus cosine x plus constant, dear students. So that is the first example in this part. Coming to second example, what is integration of ln x over x squared dx? Integration of ln x over x squared dx. So we're going to let u will be our polynomial, which is 1 over x squared, and du will be negative 2 x power negative 3 dx, and dv, I'm sorry. So for this one, dear students, u here will be ln x, and du will be 1 over x dx. dv will be 1 over x squared dx. So it is integral, dv will be integral of x power negative 2 dx, and the value of v will be x now power negative 1 over negative 1, you get 1 over x. So now the integral will be, if I'm going to call this I, so integral I is uv minus integral of v du. So I will be uv, u is ln x, and v is 1 over x minus integral of v, it was 1 over x times du, which is dx over x. So our integral is going to be reduced to ln x over x minus integral of 1 over x squared dx. So the result is going to be ln x over x minus 1 over x plus constant, dear students. So this is integration. This is integration of ln x over x squared dx. You get ln x over x minus 1 over x. You add constant. We proceed to example number 3. Example number 3, we have integral of ln x dx. Integration of ln x dx. So integration of ln x dx, here I'm going to let u again, it is ln x, and du will be 1 over x dx. The remaining part will be dv, so dv will be equal to dx. You integrate and you get the value of v is going to be x. So now integral of u dv is uv minus integral of v du. So our integral of ln x dx is uv, v is x times ln x minus integral of v x du 1 over x dx. So this is going to be equal to x ln x minus x plus constant. So that is integration of ln x dx. Dear students, integration of ln x dx is going to be x ln x minus x plus constant. We go to the last example, integration of ex times x dx. Integration of ex integration of x times ex dx. For this case, you are going to let u equals to x, du equals to dx, and dv will be e power x dx. You integrate, v will be equal to e power x. And from the formula, integration of u dv equals to uv minus integral of v du. So integration of u, it is x e power x dx, will be uv. U is x times v, it is e power x minus integral of v, it is e power x times du, it is dx. So eventually we have x e power x minus e power x plus constant, that is integral of x e power x dx, dear students. So these are a few examples actually on how we can do integration by part. But how do you decide on u? How do you decide on u and v? So for we to be able to decide easily, we are using this approach here. A helpful rule of thumb is I-led. Choose u based on which of these come first. Choose u that gets simpler when you differentiate it, and v that does not get any more complicated when you integrate it. So this is very important. The moral of the story: choose u and v carefully. Choose a u that gets simpler when you differentiate it, and v that does not get any more complicated when you integrate it. So when you see inverse trigonometric function, for example, when you see logarithmic function come first, you're going to choose as u. And when you see algebraic function, so you're going to choose as u when it comes first. Choose trigonometric function if it comes first. Choose exponential function if it comes first. And here is one of the last and tricky example: e power x sine x. So you're going to use I-let always. The point is I-let. And I-let, as you have seen, it is inverse, logarithm, then algebraic function, exponents, polynomials, trigonometric functions, and then you come to exponents. So when you have integral, for example, of e power x sine x, e power x sine x dx, how do you select? So you check, we have exponents in the last one, we have trigonometric started one. So it means u will be here sine x, dear students. You're going to let u be in sine x, and for our case, du will be cosine x dx. What about dv? dv will be e power x dx. You integrate, v will be e power x. And now the integral e power x sine x dx, you're going to the formula actually, integral v du uv minus integral of v du. So here you're going to have u, it is sine x, v, it is e power x minus integral of v, our v is e power x du is cosine x dx. So again, we cannot integrate, so we have to go further. So integral of e power x cosine x dx. Again, here we are going to use the same approach. So for our case here, u will be cosine x dx. We use this approach I late. So trigonometric come first. So u equals to cosine x, u is cosine x, so du will be negative sine x dx, and dv is e power x dx. You integrate, you get v equals to e power x. Okay, so now integral of e power x cosine x dx, you have u, it is cosine x, v, it is e power x minus integral of v du. Your v is e power x, du is negative sine x dx. Negative sine x dx. We go further now, integral of e power x cosine x dx. This is e power x cosine x minus, it will be plus integral e power x sine x dx. So we are going to go back and you are going to substitute the value of this integral here. So eventually this integral will come to be, you have integral of e power x sine x dx equals to sine x e power x plus, it is minus, sorry, so minus this expression here, which is e power x cosine x minus again integral of e power x sine x dx. So you're going to take this to the other side, because they are equal, it will be 2 integral of e power x sine x dx. You get sine x e power x minus e power x cosine x. And now you have this integral here. The integral will be integral of e power x sine x dx equals to sine x e power x minus e power x cosine x divided by 2. And this is the last answer for our integral given above, dear students. So we are coming to the end of this session. Hopefully you understood how we are dealing with integration by parts. Till next time, I wish you all the best.